Today's lesson is on similar shapes, and this is a typical similar shapes problem. Now, if you think you can remember how to do this thing, then all you need to do is go to the end, answer the question, and there is the answer. Now, if you're not sure how to do it, then listen to the video, and hopefully by the time we've finished, you'll be able to do this question and a few other questions on similar shapes. We're going to use 3 magic triangles to help us solve similar shape problems. And basically, SF stands for scale factor. So if you make a shape twice as big, so you make all the lengths twice as big, then you're going to have a scale factor of 2. But then what happens to the area if you double the length of the sides is it goes up by 4. So that's your scale factor squared. And if you look at the volume, it'll go up by 8, which is your scale factor cubed. And so the trick is, with the lengths, is to find 2 corresponding lengths in your shape. Look at the big one, divide it by the small one, that's your scale factor. So this whole thing, all of these questions revolve around finding your scale factor. Then realizing if you're dealing with area, you've got to use scale factor squared. If you're dealing with volume, it's got to be scale factor cubed. Whichever way you do it, the key to solving these problems is find the scale factor. So let's have a look at an example here. First thing you've got to do is go and find 2 sides which both have lengths on them. See, this little one here goes with that. This one here goes with that. And that one goes with that. So what have I got to do to 2 to turn it into 4? I've got to times it by 2. And that's my scale factor. So straight away we can put scale factor 2 over there. Then if I want to find y is on the little shape, isn't it? So p comes down here, y. So we know y times 2 is 3.2. So to find y, we do 3.2 divided by 2, that's 1.6. Where x is on the big shape, so he's up here, but that is associated with the 3.4. So 2 times that is going to give us 6.8. Let's clear that, and off we go to look at the next problem, which is very similar indeed. Just a little bit harder, this one, in terms of working out which length goes with which length, because they're in a different orientation, and that's something you've got to be aware of. So let's have a look. The easiest one to pick out is the length that's between the 2 angles. So the 15.2 must go with the y. Then the x goes on the other side of this angle, so that one must go with that, which means those 2 go together. And what have I got to do to 5.8 to turn it into 11.6? Times by 2. So again, scale factor 2, nice and easy. Find our scale factor. Then we look at x. Is x on the big shape? Yes, it is. And that goes with the 3.6. So x is 2 times 3.6, 7.2. Y is on the little shape, and that goes with the 15.2. So to find y, we do 15.2 divided by 2, which is going to be 7.6. Clear our drawings. Yeah. Still haven't cleared our drawings. Okay, now we're looking at an area problem, and we want to find the area of the big shape, and we know the area of the small shape. So the area of the big shape is what we want. That's what we want over here. So we want that one. And what we know is the area of the small shape is 6. But then we've got to work out what the scale factor is. And then we can see quite easily that that's linked with that. So 9 goes with the 3. So we've got a scale factor of 3. 3 squared is 9. And so 9 times 6 is 54. Fairly straightforward. Mouse. Now this one, we're looking at a volume. So the volume, it's scale factor cubed. So down here. Right. Now, if we look, what we've been given is the weight of the smaller one. And the weight is a proxy for the volume of the thing because the weight's proportional to the volume. So what we've actually got is the weight of the small one is 500, and we want to know the weight of the big one. But to find scale factor cube, we've got to find the scale factor. So we've got to look at the two lengths we're given. The big length's 49, that's 35. So that's 7 over 5, which is 1.4. So we can do 1.4 cubed down here. So if you just put that in your calculator, you will get the right answer, which is 500 times 1.4 power 3, which is 1372. So we put 1372 in there. We can put 1372 over there. Right, so now you've got to have a go at doing some. So we're going to see some questions followed by answers. So make a note of the questions, pause the video, get your answers, check your answers. And that's the way it's going to go. So let's clear our drawings. So these, again, is working with the volumes. So quickly pause the video, make a note of the numbers, and solve them. Then unpause the video and check your answers. Hopefully you got those right. Again, we're going to look at the next set of problems, which are lengths, just basic standard ones. So again, pause the video, work out the answers, and then check the answers. Here are the answers, and I hope you got them right. And the last one is practicing with the areas. Again, find your scale factor first, then scale factor squared, and away you go. So pause the video. Then when you're ready, check the answers. Hopefully you got those all right. Then the last question, we come back to the one we started with. And again, what we want you to do is pause the video, make a note of what you're doing here, and then I would go through and explain the answer once you unpause the video. Right, the answer, right, first job, we work out the scale factor. Now the two lengths which we can actually link are the 5 and the 8. So we think of our magic triangle, not so wonderful, right? L big's 8, 5, so your scale factor is that divided by that, which is 1.6. And that is your scale factor. Right, so once we've got the scale factor, we can then use it. So to go from a small length to a big length, all we do is we multiply by the scale factor. But here we want to go from a big length to a small length, so it's the length divided by the scale factor. Then finally, if we can remember what the triangle is for areas, Just draw a magic triangle for you. Oops, there we go. So the area we've been given is a big area, so he's going to go up there, 52.48. Down here, you're going to have the scale factor squared, which is 2.56. Then all you've got to do to find that is divide the 2, and you're going to get 20.5. But you've got to read the question. Calculate the area of the shaded region, which is this bit here. And that's basically the big triangle. Take away the little one. Triangle. It's not a triangle, it's a pentagon. Sorry about that. So the area of the pentagon, the big pentagon is 52.58, and the area of the little one's 20.5. If we take them away from one another, we end up with 31.98. And hopefully you've got that right, and you'll realize that similar shapes are pretty straightforward. There is going to be a second video on these, because what they've done recently is slightly change the format. All the questions traditionally were find the scale factor, use it. Now what they're doing is they're not actually giving you the lengths, and what you've actually got to find is you've got to work with areas or volumes to find either the scale factor squared or scale factor cubed. But that will be in Similar Shapes 2. So thank you for listening to Similar Shapes 1, and hopefully you've now can answer questions on this topic confidently. Thank you for listening.